Hey, welcome back to Family Physics. In this video, we're going to do number 5 in describing fields. How much work is required to move this is different mass Earth satellite from a lower radius of orbit to a higher altitude or orbit that's further away from Earth. So, doing a quick picture of what this looks like. Okay, so looks like I've drawn there. Work has to be done. Okay, so you're thinking, well, if you have to take a satellite from a lower orbit to a higher orbit, you have to get it to speed up. And get it to speed up meaning it has to leave the gravitational influence of the planet. So essentially, you kind of have to you move your satellite a little bit further away. So you're going to have to gain some potential energy. You need enough work to gain that potential energy there. But at the same time, you have a satellite that is further away from orbit. It's not going to need as much speed for it to stay in orbit. So you would have to see how the kinetic energy changes, as well as how the potential energy changes. If you had to count for both, that's going to be it's going to be tricky. But we do know that both of these satellites have a total energy at each point. So at the further away point, I'll call that total energy 2, or final actually, maybe that makes more sense. And the total energy initial, which is where the satellite is closer. So couldn't we just take the difference in the total energies and then say, since there's no energy being lost in the work being done. So assuming all this work being done is to get this satellite to a higher orbit, then we can just look at the difference in the energies. We don't have to worry about the path taken, assuming no energy is lost in this process. So let's do that. Let's take the difference in the total energies. The only difference between these two locations is how far away they are from the and hey, look at this. This already tells you the orbital radius. So whenever a question tells you the orbital radius, you don't need to factor in the radius of the Earth. The orbital radius assumes that this is from the center of the Earth. Okay, so you don't have to add that. You can just directly use these two numbers in your calculation. If the question had said the orbit is how many meters above the Earth's surface, that's when you have to add the Earth's radius. But this already says orbital radius. It's just a sweet number that you use for where the satellite is to the center of the Earth. So there we go. So substituting these in, what the total here is, I'll call this big one here, R final. I'll call this R initial. So this is what it will look like for the total energy, which we know this is just 1/2 of the gravitational potential energy as shown in the previous video. For example, 3 and 4, we saw that the relationship between total energy and gravitational potential energy, the total energy is exactly half of an orbiting object's gravitational potential energy. Key has to be orbiting, okay? Has to be in orbit. If it's not in orbit, it's not that case, okay? So here we go, bam. And this is going to be final minus the negative of the total energy. Actually, it's just the total energy over Ri. Okay. In fact, we can just move a few things out, factor a few things out on the outside, giving us the following. So I just factor out a bunch of constants outside here, which then I just have to substitute in ones. So the higher orbit is 4.2 times 10 to the power of 7. The lower orbit is 1 over 1.8 times 10 to the power of 7. Notice that we have a smaller number here, which then this whole term will be negative. This whole term will be negative. And I forgot my negative here. This will make the whole thing positive once it comes out. So let's see if it does. I get 2.849 times 10 to the power of 10, which rounding to 2 sig figs, 2.8 times 10 to the power of 10 joules. Okay, so there we go. That's how much work you have to do from getting the satellite from point A to point B without needing to consider all the changes in the gravitational potential energy, kinetic energy, etc. Just looking at the differences in their total energy, assuming that all the work done in moving satellite from point A to B, all of that work is used for that, not going to be lost, so you can just look at the difference in the energies, okay? All right, very classic example. Hopefully you got something from that video, and good luck with your practices. Fan Mama Physics signing out.